Nuclear weapons are the most destructive devices ever created by mankind. Their sheer power can obliterate entire cities, cause massive casualties, and leave long-lasting environmental effects. But have you ever wondered, how much area can a nuclear bomb actually destroy? In this article, we will explore the science behind nuclear explosions, different types of nuclear bombs, and their destructive ranges, real-world examples of nuclear bomb impacts, and the long-term effects of nuclear detonations. If you find this topic fascinating, don't forget to like, subscribe, and hit the notification bell for more mind-blowing science content from Science Kalp. Before we dive into the destruction radius, it's essential to understand how nuclear bombs work. There are two main types of nuclear bombs: atomic bombs, also known as fission bombs, and hydrogen bombs, also called fusion bombs. Atomic bombs rely on splitting heavy atoms like uranium-235 or plutonium-239, releasing massive energy. Examples of these are the bombs dropped on Hiroshima, known as Little Boy, and Nagasaki, called Fat Man. On the other hand, hydrogen bombs use a fission explosion to trigger hydrogen fusion, producing even more destructive power. A prime example of this is the Tsar Bomba, the most powerful bomb ever tested. Nuclear bomb strength is measured in kilotons or megatons of TNT. 1 kiloton equals 1,000 tons of TNT, and 1 megaton equals 1 million tons of TNT. To give you some perspective, the Hiroshima bomb, Little Boy, had an approximate strength of 15 kilotons. The Nagasaki bomb, Fat Man, was around 21 kilotons. Meanwhile, the Tsar Bomba, tested by the USSR, had a staggering strength of 50 megatons, making it 3,300 times stronger than the Hiroshima bomb. When a nuclear bomb detonates, it causes destruction in multiple ways. The fireball is the hottest part, reaching millions of degrees Celsius. Anything within this radius is instantly vaporized. For a 1 kiloton bomb, the radius is about 50 meters. For a 100 kiloton bomb, it's around 300 meters. And for a 1 megaton bomb, the radius extends to roughly 1 kilometer. The blast wave is responsible for collapsing buildings and causing fatalities. Causes third-degree burns and ignites fires. The radius for severe burns from a 1 megaton bomb is approximately 10 kilometers. Radioactive particles spread over hundreds of kilometers. Long-term effects include cancer, genetic mutations, and environmental damage. Instant deaths, approximately 70,000. Total deaths by year-end, around 140,000. Destruction radius, about 1.6 kilometers, resulting in complete devastation. Fire damage radius extends to roughly 11 kilometers. Instant deaths, about 40,000. Total deaths by year-end, approximately 80,000. Destruction radius, roughly 1.6 kilometers. Fire damage radius, around 6.7 kilometers. The largest nuclear bomb ever tested by the Soviet Union was the Tsar Bomba. The fireball radius was about 8 kilometers. The blast radius, or the area of complete destruction, stretched approximately 35 kilometers. The thermal burns radius reached up to 100 kilometers. And incredibly, the shockwave from the explosion circled the Earth 3 times. Let's take a 1 megaton bomb detonated over New York City. At ground zero, which would be Manhattan, there would be complete vaporization within a 1 kilometer radius. Within a 5 kilometer radius, most buildings would collapse, leading to millions of deaths. Extending to a 10 kilometer radius, there would be severe burns, fires, and radiation sickness. At a 50 kilometer radius, fallout contamination would pose long-term health risks. Estimated casualties would be between 2 to 4 million instantly, with millions more affected by radiation. A single nuclear bomb is devastating, but a full-scale nuclear war could lead to... Smoke and soot block sunlight, dropping global temperatures. This leads to crop failures, which in turn causes mass starvation. Increased ultraviolet radiation leads to higher cancer rates. Infrastructure destroyed means no electricity, no water, and no medical aid. Nuclear weapons are not just city killers, they are civilization-ending threats. While some might survive the initial blasts, the aftermath would be catastrophic. This is why nuclear disarmament and global cooperation are crucial for our survival. If you found this article informative, don't forget to like, share, and subscribe to Science Kalp for more deep dives into science, technology, and the future of humanity. Hit the bell icon to stay updated with our latest videos.